Hello, everyone. I'm Sindhu Chellappa, a PhD student from the University of New Hampshire. I'm here to present a paper entitled Context-Aware HTTP Adaptive Video Streaming Utilizing Quick's Stream Priority. So has the internet changed? From the days of text-based conception to image-based conception, and now we are in a generation that prefers to consume the traffic as video. But while we are watching a soccer match, and when the player is about to strike the goal, and suddenly the video drops, or while you're watching a movie, and during the important sections of the video, for example, the climax of the movie, and suddenly the video drops, this will not lead to a happy user experience. And hence, we are here to present a scheme to prioritize to first identify the important segment of the video and to prioritize by means of quick stream priority. And before I get into that, just a small introduction about TCP and quick. We have been using TCP for about 4 decades. And when we talk about TCP, it is going to be operated over the IP layer. It is reliable, it is connection-oriented, and by means of HTTP2, a TCP connection would be able to handle multiple HTTP streams, and hence it requires, for a connection establishment, a 3-way handshake, which is a ping signal to establish a connection, and also all the data goes over a single stream of bytes as clear text. Whereas in Quick, the RFC 9000 came in the year 2001, and even though Quick is a reliable protocol, it operates over the unreliable UDP, and within a single Quick connection, there are multiple independent HTTP streams. And hence, it can establish a connection to as less as 0 round-trip time, and all the data is encrypted. So if we just quickly look into how the protocol stack looks like, all the details from the TCP layer, for example, in the security layer, TLS 1.2 is integrated into the transport layer of Quick, and whereas in the application layer, the multiple streams is integrated within the transport layer of Quick. So within the transport Quick layer, it is reliable, connection-oriented. It has its own congestion control algorithm. So we have a choice of choosing between BBR or cubic, and even to enable hybrid start or disable hybrid start. There are several options that can be tuned on. And also, all the data is encrypted. It has its own multiple streams within the connection. And this led to HTTP 3, in which within a single Quick connection, there are multiple HTTP streams, and also because of the change in the streams that is being delivered, there are different header compression strategy for HTTP 3. But now it's time for us to look into the prioritization scheme. So the RFC 7540, which is an HTTP2 prioritization scheme that came in the year 2015. The scheduling is accomplished in the server as a form of dependency tree. But how the scheduling is done and how the bandwidth distribution is done is the parent nodes are transferred in full before the children nodes. And also, the sibling nodes share bandwidth if they have the same weight. But this led to several drawbacks, which are head-of-line blocking. So while using a prioritization scheme, and if a higher priority stream is being blocked, and hence the other data is also being blocked, and hence this led to head-of-line blocking. And when resources are being for the prioritized segment, if there are several clients who are competing for the same resources, which resulted in resource contention, and the implementation is very complex because of the dependency tree being restructured, and also it has limited browser support. Safari and older version of Internet Explorer do not support these, which also has led to interoperability issues, which is proxies, load balancers. They might not be aware of this HTTP2 prioritization scheme. So to make this scheme a simpler one, the RFC 9218 which is the extensible prioritized scheme for HTTP, which came in the year June to 2022. So what do they define is, we want to keep this prioritization scheme as simple as possible. For that, they specify the urgency parameter. What do I mean by this urgency parameter is, in what order should I send the data? So this urgency parameter is defined between 0 to 7. So if it is urgency 0, which means that the data has the highest priority and that should be sent as soon as possible. Whereas urgency 7 means it has a lower priority and that can be done as a background job. So the smaller the value, the higher the precedence. And also there is one more parameter which is known as incremental flag. So what do I mean by this incremental flag is, the HTTP responses can be processed incrementally. So which means that incremental can be directly correlated to concurrency, and if it is non-incremental, you can think of sequentially giving out the responses. So incremental is a Boolean value. It is by default, the spec specifies to define it as false. And the main motivation for this idea is, YouTube recently came out with the idea of the most replayed feature. This idea exactly came out, YouTube rolled out this feature to the public in May 2021. And also right now, if you check YouTube, you would be able to see this engagement graph. What do we mean by this engagement graph? Users would be able to see what is the portion of the video that the majority of the users are interested in. So no matter how long the video is, there are important segments of the video that the users are interested in. And what I'm here to propose is, how do we prioritize these important segments of video by means of quick stream priority. So before I step into my proposed approach, I would like to show how the state of art will behave without these prioritization scheme, but over the quick connection, so which is a sequential behavior. So now let's say that the origin is supporting quick, and the video is being encoded at different bit rates. And the manifest file has all the details about it. Now the client is going to request for the manifest. So when the client is going to get the details of the manifest, and the manifest is given to the client, and then depending upon the adaptive bitrate algorithm that is running on the client, it is going to decide on the bitrate of the segment, and the request for the segment goes, and the response is coming back to the client. But what happens in the quick connection is, since there is no priority specified, or within the streams, the data is being sent in a sequential fashion. By what I mean by that is, when the first segment is being delivered, the server will send the next segment only after the first segment is delivered. So there is a sequential flow of segment delivery, and also since there is no priority specified, it is just going into the medium priority queue. So what we are proposing here is, what if we find the important segment, and how can we send the important segment over the prioritized scheme? So right now, on the origin, which supports HTTP 3 over quick, in the origin, we are going to identify the important segment, and after that, we are going to tag the important segment. After the tagging process is done, the segments are, obviously it is encoded into different bit rates, and those important segments have the tag. So we are just basically distinguishing the important segment from the non-important ones, and also we are updating this information into the manifest. So after this information is updated into the manifest, now the client requests the manifest. And when the client obtains the manifest, the client learns about these important segments. So once the client learns about the important segment, and when the request for, after the adaptation logic runs, and when the request for that segment goes, the client is going to ask the request with the priority hints. So if it is an important segment, then the priority levels will be set. For example, let's say, if the client is going to ask the request for the priority hint, it would be the highlighted one, which is the priority flag will be set in the request, in the HTTP request from the client to the server. So by which, because all these priorities have to be identified only by the requested by the client. So the client will request and this priority with the priority flags. And then the server will prioritize the segments based on the request of the priority hints that is requested from the client in the prioritized quick stream. So what happens under the hood is, so now let's say that there is one segment that is requested at a lower priority, and before the segment for the important segment is requested, now the change that we are doing in the client is we are going to request the previous segment, but the important segment is going to be, the request for the important segment is going to be initiated in parallel with the previous segment. So why do we do that? Because this important segment is going to go over the higher priority stream, and also we are going to request the important segment at a higher quality also. So we are initiating the request parallelly with the previous segment, and hence it will result in the bandwidth sharing of the resources without degrading the quality. So we make the client aware of the important segments, and also we request those important segments by means of the priority hints, and thus we take advantage of the quick stream priority. So as a future work, we plan to integrate this proposed scheme with low latency algorithms as a part of Dash.js, and also we plan to design an ABR algorithm to support the proposed design. And we also want to extend the scenarios to multiple clients, various combinations of prioritized segments. And we would like to do a root cause analysis with QLog and QVis, which are logging tools of Quick. So, thank you.
Any question? Important segments.
Thank you for the presentation. So if I understand correctly, that the origin know that the segment is important. So why does the origin send that segment in a priority way? It's not. It doesn't need a hint from the client.
Can you say that once more?
Okay. So because what I understand is that the origin understand that the segment is an important segment. So it's know that when it delivers that segment to the client, because that's the important segment, so it sends it in a priority scheme without requiring the hint from the client. Yeah. So why do we need the hint from the client? Yeah.
So let's say that if in the important segment, if an important segment comes from if the client is requesting for an important segment, they're going to add the priority hints. But whereas if the client is not, if it is a non-important segment, no, there will not be any priority hints that is going along with the client to the server. So without any priority headers that is set over the HTTP header, it would be transported over the normal streams, which is, the default stream is 3. By default, in Quick, the default stream is 3. So which you could assume as a medium priority stream, as a medium priority queue from in the data structure. So just in the medium priority queue, all those data will go. Whereas in the highest priority segment, there will be high priority queue, which will be transporting the data as quick as possible. So if there is no indication of the priorities, then it would go in the medium priority queue.
Okay. Thank you.
Yeah.
Thank you.